Welcome one and all to this, our third in the series of webinars where we've been covering various topics in and around efficiency, data centers, HPC, etc. Not only do we have a wonderful, wonderful special guest lined up for you today, but also we've got a couple of additional people who are here who've been helping us prepare and who are here also going to participate. I would like to briefly introduce myself. My name is Diarmuid Daltoon. I look after sales and marketing for Submer. Submer, we're based out of Barcelona and very soon also based out of the Bay Area in the US. Also, I'd like to introduce the wonderful Mr. Jeff Hardy. Jeff Hardy has been helping us on communications and on PR for the last couple of weeks. It's been an absolute pleasure and is an absolute pleasure to work with him. Also in the background here today, we have Mr. Matteo Mezzanotti. Matteo looks after communications and PR for Submer internally. So, it takes a team to put together things like this. I'm very, very grateful to everyone. Okay, so a little bit just about how we're going to run this session today. We will save time for Q&A at the end of this presentation. So if you do have a question, please take the time to write that question in the chat section, which is to the right of the YouTube video during this presentation.
And it's worth saying right now, John is with the OCP, and OCP is doing some brilliant work. And it's not just in the cooling and energy and data center work that we're talking about now. They actually have a broad-based set of specifications that they write across networking, servers, storage, rack and power. Of course, Submer is deeply interested in advanced cooling and a participant there. Data centers, telco, hardware management, open sys firmware, HPC, and security. And it's worth saying that, it's time that, if you're consuming this content and this is of value to you, if you're a professional in this industry, you can get involved too. And it's a worthwhile organization to participate because it makes it the end users, we consumers who are using these products to make life better for all of us, are getting together to take and help create a better future through technology. And it's a great way to participate in that environment.
Thanks, Jeff. I think without a further ado, we would love to introduce to you our special guest for today, Mr. John Laban. John has worked in the telecommunications and data center industries for many years. He's not letting me say how many. He began his career at the London Stock Exchange as a BT telecommunications technician. And I think most of you know that you can meet John at almost any convention in Europe. We suspect that the OCP guys cloned him in some way to have him everywhere. We don't know how they do it, but they're a little bit further on than everybody else. But John is out there educating about OCP, data center design, and energy efficiency. And that's the capacity in which we'll be talking to John today, focusing on that energy efficiency. When you talk to John, you can really feel his genuinely contagious passion for technology. He's been voted as one of the top 10 movers and shakers in the UK data center industry. And in 2017, John was voted a top 50 influencer in the EMEA data center industry because of what he's been doing in and around OCP. John, you're super, super welcome, and thank you for joining us from London today. Anything you care to add about yourself? Maybe something about what you do on your downtime, if there is any?
That I'm in Suffolk, in an old house in Suffolk.
Oh, okay.
Not to worry. So well said, well said.
Okay, fantastic. And John, if you'd like to maybe just to take it away and to help the audience here through your particular points so that we can get also to that very valuable Q&A session at the end of this.
Okay, thank you very much. Well, you know me. I think there's quite a few people listening to this or watching this that will know me personally. But what I plan to do is just walk you through some of the disruptions that have been brought on by the Open Compute project. The Open Compute project started in 2011, and it's been disrupting the data center industry considerably. But it's been a little bit invisible to lots of people in the traditional enterprise data center industry. So let's just walk you through a few bits. Now, the first thing, you're looking at some books there. Now, I would recommend you read those books. The first book on the left is a really good book about the impact of cloud, the big switch. I used to own a company that designed and built data centers. And when I read that book back in 2009, I think it was, I sold my company because it predicted the way cloud solutions were going to destroy enterprise data centers. So I'd recommend you read that book. The next book is The Power of Habit. Read that book because you need to break out of the old ways of enterprise data center design and build and operations. The next book will give you a deep understanding about what's happening in the market with these disruptive technologies and where we are today in terms of the dispersal of this disruptive technology of open source hardware solutions, including open source software, is what we call that blue area on the front of that book, Crossing the Chasm. It's known as the tornado phase. It's the point where it starts, the technology starts to explode into the market, and we find ourselves in a position where we haven't got large enough supply channels. And that's the crazy situation we're in now in Europe, where we have a very small supply channel for a huge growth curve, which is coming so fast. The next book is Zero Marginal Cost Society. That will give you a good idea on how you integrate all these technologies into power systems and the Internet of Things. And the last book is all the social impacts it's going to have, which is going to be considerable. Now, I've asked Jeff to put this continuous improvement cycle in. I'd recommend you just use this as a methodology for when you've got difficult problems. I find it extremely useful. When you start moving into these technologies, you'll find that you need to develop new ways of looking at problems. You can't use the old linear systems. If anybody's interested, you can contact me afterwards or contact the guys, but there's a whole new way of thinking called design thinking, and it helps you solve problems in a non-linear fashion. And with very disruptive technologies that are coming from the open source communities, I recommend that you start changing the way that you look at problems. You'll be left behind if you don't. Now, what this is the energy in a typical enterprise data center, a tier 3. Now, if it had a PUE of 1.6, this would be perhaps the way the energy would be distributed throughout that data center. You got 2 kilowatts on communications, 3 kilowatts security, ventilation, 15 kilowatts light and power, 35 kilowatts distribution UPS losses, and then the big one, 240 kilowatts cooling fans, pumps. And then the IT load comes in at 500. And PUE is just a measure of the efficiency of the way the utility works. Now, PUE is kind of going to fall to the wayside very, very quickly because of what's happening with combined heat and compute, the way we're reusing heat from the data center. But just a few points looking at this. If you look at the 240 kilowatts for the cooling fans and pumps, if you remove the mechanical chilling, i.e. the pumps, you could reduce that figure by about 80 to 90%. Now, some of you people who are using conventional enterprise data center be using DX refrigeration cycle systems. We don't use those in OCP data centers. And the reason we don't is because you need to use mechanical chilling, and mechanical chilling is extremely wasteful in terms of energy. Now, here's a traditional data center. You've got the centralized UPS, you've got centralized chiller systems, you've got the IT load at the top right there. So this is what you would traditionally see in an enterprise data center or a large colo, a traditional one. If we move on to the next slide, what we do in the OCP community, we basically take out all the chiller systems, the mechanical chilling systems. We use very, very simple cooling systems. Sometimes it's direct air, sometimes it's indirect air, but it has a substantial impact on the energy required for the overhead of the facility. If we look at the next slide, you'll see what we do as well. We optimize the data center by removing the centralized UPS. Now I'm going to show you some schematics in a minute just to show the impact that has on energy efficiency. But there's also something else that's an issue when you've got centralized UPS systems. It gives you a major failure point, even though you've got kind of dual systems running in redundant modes. It's often the place where you're going to see the major problem related to that centralized UPS function. If we move to the next slide, you'll see how we do it in an optimized OCP data center. So what we've actually done now, we've removed the centralized UPS, and what we've done within the IT load in the computer room, in those racks, we've embedded lithium-ion battery backup units. Now, if we go to the next slide, you'll start to see the energy savings on doing this. Now, at the top, what you've got is the traditional electrical path. And the thing to make a note of is the conversion steps. Because when you have to go through the conversion steps, that's where you actually waste energy. Now, compare that to the powertrain at the bottom on an OCP data center. This is a Facebook powertrain. You can see there's very, very few conversion steps. You'll see the battery backup units actually within the rack down on the bottom there, that grey elliptical box. Now, as you can see on the top, you can lose a substantial amount of energy just going through these conversion stages. You could lose 20% of all the power that you put in, all the energy you put into a traditional enterprise data center can be lost as overhead just on the facility on these conversions. Whereas when you start to look at this cleaner OCP solution, it can get supremely efficient. And on some of these solutions, I've seen 97.5% efficiency. So instead of losing 20% of all the energy, you're only losing a few percent. We'll go to the next slide. I want to touch on this because people don't realize the significance of how software makes these systems much more energy efficient. And the way they do it, this software, this open source software, it consumes the hardware. So if I walk you through this, we just click to the next slide, to the next, that's it. And then click one more time. And what you'll see here, prior to 2008, we had servers with no virtualization. Then we brought in heavyweight virtualization. Now, what heavyweight virtualization? It's because you've got what's called a hypervisor involved in the virtual machine, because you've got different underlying operating systems. So you might know the heavyweight virtualization VMware. Now, what's happened in the last few years, we've moved to lightweight virtualization, something called a Linux container. Now, what's interesting, as you go through these stages of virtualization, you reduce the hardware. So if we go back to pre-2008, and we've got 10 physical server nodes. When we implement the heavyweight virtualization, we reduce the hardware roughly by 33%. And then when we move from the heavyweight virtualization to the lightweight virtualization using Linux containers and Kubernetes to manage this, you get about another 66% reduction in the hardware. And the reason you do is because you're running more workloads on the same physical piece of hardware. So if you go all the way back to 2008, you'll find that the CPU utilization on those servers will be around 6%. So they're very, very underutilized. Now, what virtualization does, it allows you to utilize that hardware by pushing up the utilization on the CPU in order that you can reduce the hardware. So this is significant. And this really is what cloud is about. And this is why the hyperscalers are gobbling up the enterprise data centers, because a lot of the enterprise data centers haven't implemented this. If we go to the next slide, you'll see this is an example of what Facebook did. They were building out their infrastructure. A very, very large part of their server hardware infrastructure was web server nodes. Now, how can we grow? They couldn't grow fast enough. So they started to look at how they could utilize that hardware more efficiently, those web servers. And they gave the problem to some software engineers. The first thing they did, they developed a new programming language, a new open source programming language called Hack. And then using this open source programming language, they developed something called a hip-hop virtual machine. And by applying that hip-hop virtual machine, they reduced the physical server node requirements by 80%. Now, this is just software, just software. It puts everything that we've been trying to do with all this energy efficiency by looking at the PUE factor and optimizing the data center, it makes it look totally insignificant, what we've been doing with software. If we go to the next slide, there's a lot more work happening with software. Now here, there's a very interesting research project based up in Boden in Sweden. It's near the big Luleå Facebook data center. And what the OCP community and Facebook have done, they've given this research project over 2,000 OCP servers. And they're doing some fantastic research up there. Now, in the middle, you can see that wooden building. That's actually a data center. It's probably one of the most efficient data centers in the world today. And there's some really clever things happening. And one of the things that I discovered just recently, talking to this chap, and I recommend you all go and find him. He's a very special guy from Leeds University. They set up a brand new business. And his name's Paul Townend. And the company is called EdgeTick. Now, what they've done, they've started to run software on these servers. And this software has reduced the energy consumption on the servers by an additional 20%. So as well as all the virtualization stuff, they're now getting another 20% reduction with this software. Now, I think this really will take off. And as I say, this is all research work. You're all welcome to go and visit this place. And on the top left-hand side, that top left-hand side picture is a guy called John Submer, who's from this research institute called RISE, the Research Institute of Sweden. And if you contact John, they always have open days and they're always willing to take people in. And it's a really innovative thing that's happening now.
Hey, John, when we were talking about this slide the other day, we kind of got off on a bunny trail, but it's a really important extra topic that you emphasized right here. And it's the difference. It's why open source is important economically in this, because what it's doing is research projects like this and being funded by the OCP and coordinated with the OCP is turning economies on their side by, instead of having a supplier-driven product cycle, it's really making a consumer-driven product cycle. Is that correct?
Yes, and the concept in the book at the beginning, the book called Zero Marginal Cost, there's a concept called a prosumer, and it's a consumer that gets involved with the design of the products and services that they take. So let me give you one example of the way these prosumers, a prosumer like Facebook or Google, these big players, these big kind of early adopters, these big change makers, because these are the guys who came in and kind of started the OCP Foundation, and it really in the beginning was a big buyers club. And they were very, very motivated to do things to benefit themselves, i.e. getting more workloads on a piece of hardware, getting energy efficiency for these big data centers. Now, what was interesting, virtualization had been around for a while, but it never really exploded until the prosumer developed these lightweight virtual machines, these Linux containers. And I would argue that the traditional hardware vendors, the proprietary vendors, had no motivation at all to encourage that kind of technology, because basically it was going to kill their server business. So it's nice we now have the consumer changing the whole marketplace. And because these hyperscalers are so big and powerful, that's why it's happening.
Brilliant. Good, great point. Thank you for expounding on that.
Let's have a look at the next slide. Now, another application of software is there's a company that Google purchased a few years back called DeepMind. They're based in London. And they started running AI software in Google data centers. And this was the outcome. They reduced the cooling bill by 40%. Now, you've really kind of got to start looking at the software. The software is what's eating the hardware. And I would all recommend you start learning a bit more about the software, because the impact is so significant. It is so significant, and there's a lot more to come from it. Next slide. Now, just a few kind of questions. Part of that review technique, that kind of way of looking at problems, you ask the question, why are we here? Why do we do what we do? Now, what this is a traditional enterprise server. And I ask the question, why do we put all the interfaces on the back? Well, in a traditional server, we put them on the back because fundamentally what an enterprise server is, it's a desktop PC that somebody decided to pick up off the table and put into a rack because they didn't have enough table space for all the desktop PCs that created their server farms. So that's the reason why all the interfaces are on the back, because you don't want all the cords coming off the front of the table, you want them going off the back of the table. Now, if you imagine you've now got all these servers sitting in a rack, you have to work at the back all the time. Well, you don't want to work at the back because it's hot at the back. So what the OCP community did, they basically reinvented the server. You don't go to the back of an OCP server rack, you do everything from the front. And what they did, they started to eliminate gear. So let's go through and show you what they've eliminated. The AC to DC power supplies, they took them out. The outbound management's done differently. The keyboard, video and mouse, well, you never use them, so why put the circuitry inside? Multiple operational Ethernet ports. When you start to use virtualization using lightweight containers, you can get away with just 1 or 2 Ethernet ports. So this is basically what they've done, and all we've got on an OCP server is 1 or 2 Ethernet ports on the front, because when you plug the server into the rack, it just clicks onto a bus bar, a DC bus bar. So it's very, very simple. And you achieve very, very high ratios. So if you were in a typical enterprise data center, you might see one hardware server technician to say 250, 400 servers in a good install in enterprise space. But if you're in an OCP data center, I think Facebook now are announced a conference I saw in Dublin last year. that they're achieving one hardware technician, server hardware technician, to 48,000 physical server nodes. That's a 99% reduction in people. Let's have a look at the next slide. Now, what I'm going to do now, this is a 40 server rack. And what I'm going to do, I'm just going to rip out all the stuff and convert it into an OCP rack. Now, if I can just describe what the items are, the blue things, horizontal lines at the top, they're Ethernet switches. The red boxes are the AC to DC power supplies. The grey lines in there are the 40 servers. The little orange circles are these 40mm fans that you get in these pizza box servers. The green things at the back are the intelligent power strips that cost about $1,000 each. And then you've got the airflows into a downflow crack unit going under the floor. Now, what is going to happen now, we're going to start to rip the gear out and throw it away. So we throw away all those fans, hundreds of them. We throw away all those AC to DC power supplies, and we've got 2 in every server and every switch. We throw away some of the top of rack switches because we don't use them anymore in the same way. We throw away all of those $1,000 AC to DC power strips. We throw away the downflow crack unit because we don't do it that way anymore. We remove the floor. You don't need the floor. And we throw away all that cable spaghetti that's in the back of the rack. And here's what we've kind of thrown away. Now, what's interesting, the cost of all this gear is a lot of money. It depends how it's configured and how you've laid it out, but it could be anywhere between $10,000 to $16,000 per rack for 40 servers. $10,000 to $16,000. Now, I've not really gone much into the capex on building a data center facility, but you can build an OCP optimized data center facility at about half the price of a traditional enterprise tier 3. So the big cost driver, OCP, why do people adopt it? Because it's hugely beneficial in terms of cost. That's why people adopt it. Let's have a look at the next slide. Now, just to give you some idea about how things have changed on the server configurations, and we haven't got time to take you through all the servers, but if you look at that top row, you've got these 40mm fans. Now, they're the fans inside a traditional pizza box server. They can't be bigger than 40mm, and there'll be about 6 or 8 fans inside. At the bottom, we would OCP server as a different physical profile, and we would put, say, 2 80mm fans in. Now, there's something that you probably all learned when you were at school. I knew this when I was at school when I was 16, when I was doing physics in school, and it's called the fan cube law. And the fan cube law is this. If you reduce the speed of the fan by 50%, you reduce the energy to spin that fan by 7/8. I hope you got that one. Reduce the speed by 50% and you reduce the energy by 7/8. So if you look at these configurations, the top row, and then you've got the 2 fans at the bottom row, the 2 fans at the bottom will use nearly 90% less energy to push the air through the server than the fans at the top. Let's have a look at the next slide. Now, another thing that happens with OCP, we use higher rack units. And the good thing about a higher rack unit, deeper, we can get big heat sinks. And when you've got a big heat sink, you get the heat off the CPUs much more efficiently using less energy. So that's another reason why we like them to be bigger. Let's have a look at the next slide. Now, the next stage after you've used the fans and you've optimized the fans is to take the fans out and to use liquid heat transfer. And this is where Submer have come in, and there is a really interesting group that started last year on advanced cooling, and I'd recommend you to all get involved and have a look at that, because it's really quite special on where it takes data centers in the future towards this concept of combined heat and compute. Let's have a look at the next slide. So just taking the heat away, the small pizza box servers, they use lots of energy. The OCP servers, they reduce it. And then you reduce it even further when you start to look at liquid heat transfer. So this is key, and this has a significant impact on the data center. And I think if I asked Dermot to kind of throw something in, he would tell you all about, you can increase the density now inside a single rack considerably. Yeah, and this is coming very quickly.
Yeah, you can bring it from anywhere from 50 kilowatts, and even in colder regions, or if you're using some form of a chilled water, up to 280 kilowatts in that same rack footprint. And what was really interesting when we were talking about this previously, John, was also the fact that you were saying even in those cold climates, and even where that research is taking place, that people are still super interested in liquid heat transfer or liquid immersion cooling. And maybe just very briefly, just going into why, because I think it'll be hard for some people to understand why, if there's all this efficiency gains and everything happening with OCP, and if they're in this kind of a cold climate, why they would still have additional benefits.
Okay, well, one of the biggest drivers towards liquid heat transfer is the amount of heat that's being generated in a rack. The OCP Foundation commissioned some research work with IHS Markit last year. It was published in October. And they went out and interviewed people around Europe that run data centers. And of all the people that they interviewed, 22% of them said that within the next 2 years, they would adopt liquid heat transfer. And what's interesting, 22% of them also said they'll be doing waste heat reuse, because there's this magic kind of thing that happens when you start looking at the two. But we're going to move into liquid because we're now rolling out in some of these OCP projects, we're rolling out 30 odd kilowatt racks. And that's really the upper limit for air cooled. So no matter where you are, you will be moving towards liquid. And it's going to come quite fast, I believe. But there's a really lovely kind of benefit from the liquid. It enables you to reuse the heat much more efficiently external to the facility, the data center. Let's have a look at the next slide. Now, this is just showing you the impact of the fan technology and the way the power supplies work in an OCP server. This is a piece of work done by SK Telecom, and basically it's just showing you that when you're at low utilization and idle, an OCP server, fan-based server, air-cooled, is going to use 50% less energy. Now, why I've kind of focused on this as well is because there's new EU regulations coming in, and they're coming in 1 year from now, in March next year, and there's going to be regulations on the energy efficiency of servers, on new servers sold in the European Union. And one of the things they're picking up on is energy efficiency at idle. This is going to be very interesting. You just watch this space on this legislation. A lot of it was all developed from research that was done at the University of East London under a project called the Eureka Project, if anyone wants to know more about it. But if you're in Europe, you should become very aware of this regulation, because it's going to have a huge impact, and the legislation breaks in 1 year time.
All of our US as well, John. I think they're going to be maybe thinking we're very much pushing the EU angle, but I think we all know as well a lot of the work regarding efficiency and a lot of the legislation regarding efficiency is really pushing things to the forefront, or really pushing the envelope there, whereas these particular legislations don't exist today in the US. However, there'll probably be something similar.
Absolutely. One thing you need to be aware, the guys in the US, all the people in the US there, you will see a change, because when these big manufacturers, some of them you may never even heard of, some of these big manufacturers who make these OCP servers, they're not going to make a product that's less energy efficient for the US market. They're going to make it for to meet this regulation, and then they'll sell it globally. And if the Americans come in with tighter legislation, that's what they'll always capture. So when a big kind of continent like Europe or America come in with legislation, energy efficiency legislation, those manufacturers will meet that, and that will be the commodity that will be sold globally. Next slide. Now, there's been a kind of a hidden revolution. These are the old standards, and you know, in terms of energy efficiency, we've been improving. But what's happened because of the hyperscalers and the OCP, there's been a hidden revolution that's occurred, and it's now starting to move into the enterprise space and government space and the telco space. All the world's telcos are adopting OCP technologies. And it's really quite profound, and it's just starting to come into your enterprise data center space. And the growth of interest is huge. I'm currently spending about 30 hours a month just on LinkedIn because I'm getting over 1,000 followers and connections every single month. Let's go to the next slide. So just a few little takeaways here. If the world were to adopt these open source vanity-free infrastructures today, and they're mature, by the way, they've been used for some time, the energy used by the world's data centers would reduce by at least 50%. Let's look at the next slide. You need to understand what happens when you move into open source communities. Innovation happens really fast. The Genomic project was an open source community. Back in 2001, it would cost you 100 million to get your genome mapped. Today, it's less than $1,000. Look at it compared to Moore's law. Open source communities do things so much faster than proprietary players. Let's have a look at the next slide. Now, this is the idea of heat capture. Now, you'll hear people calling waste heat reuse, but this is where I think liquid heat transfer is really going to come into its own, because when you start using liquid, you don't need intermediate heat pumps to give this useful heat to take it into a district heating system. And this is going to be huge up in the Nordics because they have established district heating systems. And hopefully on this particular seminar, there might be some people there from the Stockholm district heating solution who are doing this now. So if you want to go and see this in real life, go up to Stockholm and have a look at it. Now, if we move to the final slide, if we can now integrate all that magic from the open source community, plus combining this combined heat and compute, using this heat external to the data center, you're in a position where if we applied it tomorrow, we could reduce the amount of energy required for the world's data centers by 80%. And lastly, there might be a few things here that I might have killed a few babies. The idea of removing centralized UPS, removing chiller systems. Now, there's something called the Kubler-Ross curve. And what this is, it's when somebody close to you dies. On the left-hand vertical, what you've got is morale and competence. Now, first thing, you often find you go into shock. And over time, you go through these phases, these emotional phases. You go through denial, you get frustrated. What is it quite interesting? I want to leave you here depressed. I would love to move you off the denial stage, because there's so many people who are in denial stage in the enterprise data center market. And enterprise data centers are shutting at a rate of 10% per annum. And they are not moving, and their businesses are really suffering, and they're going to go broke. So if I leave you depressed, then the only way is up. So thank you very much.
So, John, thank you for ending that on such a positive note there, really. Talking about killing babies and leaving people depressed. Excellent. I assure everybody no babies were killed in the making of this. Now, we have a couple of questions, and actually we have a couple of people who've responded very nicely, I would say, to some of the provocative things that you were saying, John, and I'm sure you're very used to these kinds of reactions to some of your let's say, I won't call them broad or sweeping, but to some of those statements. You know, we believe, of course, that we have the technology today to really do something about the consumption of data centers, which is really way too much of the world's energy and has way too much of an impact on it. But there was a funny reaction to when you said vanity free. And I know when we were preparing for this, I also had a chuckle at this. So maybe you can just go into very quickly and talk to us about the vanity free expression.
Well, the term that's used is the very first servers developed by the OCP community. They were called freedom servers, and they were free from the proprietary lock-in of the traditional vendors. And the team that kind of developed this, they made them vanity free. They took away all the logos. They took away all the bezels. They basically said, this is an engineering item. It's not a piece of sexy marketing. What value do we get from having logos on these devices? So they basically stripped it all back, and they kind of optimized it and optimized it and optimized it using value engineering methodologies. And they got to this point where they were vanity free, i.e. they had no gloss on them. And also, it was quite interesting, they were striving all the time to remove gratuitous product differentiation. So if, for example, you were looking at the AC to DC power supplies in a traditional server, you will find hundreds of them. And each one of them only fits a particular piece of hardware server. You cannot move them between servers. And this is the kind of the differentiation that the traditional vendors put in order to lock you in to their services and their products.
When we were discussing this beforehand, we also covered the new speed of the life cycle of the development of new hardware, where you were saying that it went down from years down to a number of months. Maybe you can also touch on that for a moment.
Yeah, what's been happening, the hyperscalers, let's give you an example of how quickly you'll see a product innovation. So if you go back just a few years in the OCP Foundation, they wanted to develop 100 gigabit Ethernet switches, and they wanted to develop them so that they could be sort of managed very, very simply. So they kind of wanted to create this idea of an Ethernet switch managed very, very simply like a server with lots of Ethernet ports. So what they did, they embedded a kind of a micro server inside the switch. Now, that was the idea. And just to let you know, from the point where the idea started to when they were shipping these out by the tens of thousands into the hyperscalers, and these products were called Wedge and Six Pack, if you're not familiar with them. And it took about 3.5 months for them to actually be shipping them. Now, if you're working in a proprietary kind of situation where you've got a few people sitting in a room, that would take significantly longer. Now, what was interesting about these products that were developed really, really fast, 5 to 10 times faster than the traditional hardware, is some of them are 80% lower cost. So this is what OCP communities do, open source communities. They work together, they have these hackathons, they come together and they do things really quickly.
Okay, we've got another couple of questions here, John, especially regarding, are there specific HPC designs for GPU servers, etc.? There was just a couple of things regarding the question of whether the advance of genome processing really was due to accelerators like GPUs and not just open source. Maybe you can touch on that as well, please.
Well, just looking at the impact on the genome project, the thing that really accelerated the Genome Project was a declaration in, when was it? I think it was in Bermuda in 1997. The genome community, as it was developing, they knew this was a very, very difficult problem. So they all got together in Bermuda and they sat down and they said, if we share information, so if we discover anything, we would distribute it on the internet within 24 hours. And this was called the Bermuda Principle. And I think it goes back to 1997. Now, as a consequence of that, this is why the genomic kind of cost curve fell really quickly, because anytime any researcher was working on the Genome Project, part of this agreement, they released all the information within 24 hours into the public domain for everybody. So that was really the big driver. Now, if you want to know more about this, you can go and have a look at some really good research. But I did a presentation last year in October in Amsterdam, which talks about the impact of open source technologies and the open source environment and what it does to innovation. And some Scandinavian players now are really into this. If you go to Denmark are now trying to push open source manufacturing within their manufacturing industry because they can see all these positive benefits. So that's and it's about being human, really. If you commune and share, you do things faster and better.
Okay, another question we have here now, maybe a little bit more related to a topic where I have more of a grasp of, immersion cooling, but asked, are there additional benefits, for instance, server life increase, power consumption decrease, etc., for supplying chilled water to immersion cooled servers? I think that for most people who know Submer and know what we're on about, it has to do with the maximum efficiency. And it means, of course, trying to leverage the ambient air temperatures in order to reduce the secondary cooling loops, to reduce the temperatures. However, where we are talking about increasing the density and where that is the focus, and there would still be benefits like an extended server life, because you can run your hardware really at full tilt. You can unleash it, for want of a better term, and you will still keep it within those temperatures. And also it means the footprint that you'd be taking up, so it would be much smaller. We're also have a question here, and this to you, John. Are the servers going to then be universally made?
Well, I was talking earlier about the idea of removing gratuitous differentiation. So let's give you an example. If I've got a HP blade center and a Dell blade center, I can't take a Dell server blade out of the Dell blade center and stick it in the HP. They are totally incompatible. Now, if you start to look at a typical OCP configuration, the rack is actually the blade center. And the products are made so that you can get different manufacturers making identical and similar servers that just slot into this rack. So you might have an OCP rack, and inside it you might have servers made by 6 or 8 server manufacturers, all in the same chassis. Now, special because it's really good for large enterprises. For example, Booking are playing with this gear now, Booking.com, and they've got this problem that they need to get supply from two supply sources, 2 different manufacturers. So that means that they've got this kind of confused mess of incompatibility between HP and Dell, but they have to use both. Whereas when they move to OCP, they can buy from different manufacturers, but they buy the identical homogeneous solution, so they don't get this confused situation.
Of course, there's also the price advantage, which is one of the biggest drivers. Maybe just because as we're coming to the top of the hour, and to end with a very interesting point being made by one of our viewers, that there aren't really any open source alternatives for many of the components in a server, and I think that was specifically aimed maybe at the CPUs. Maybe you could end or help us to finish off with a nice commentary on that.
Yeah, that's the elephant in the room, because when you look at the server, you can go and get the design of the server, the design of the motherboard, the design of all the kind of fabrication of it, and you could make one in your garage. But the components that you install on the motherboard, like the CPU, they're not open. So yeah, that's the elephant in the room.
Okay, and, although we know of the European CPU project, have you any information on that?
Yeah, there's moves to try and open up the what's going on with the CPUs, with the processors, and there's a very interesting project to build a huge supercomputer in Europe. And quite funnily, it uses an OCP rack, and it's just rammed full of ARM processors. And I think it breaks in at about 96 kilowatts a rack, all using liquid heat transfer. But there's something called the Open Power project, which is IBM releasing their processor kind of technology. But I think that I'm sure the hyperscalers would love to move into the processor market, and quite a few of the major hyperscalers are developing now their own processors. You can go and have a look at them. So let's see what happens in time. But yeah, it's not truly open source right the way through to every component.
Okay. Really, what remains for me to say here is, John, thank you so much for the time you've put in, and also for what you've shared. I believe there's something in here for everybody. We've touched on most of the questions. Anyone who wants to reach out to us afterwards, please do. We will publish this, of course, to our YouTube channel. It'll be there in perpetuity or something like that. We will be coming to you again next month. I believe our focus next month is going to be in and around education and what's available in and around the data center industry. More on that in the coming weeks, and I'm sure we'll be communicating with you via email and via social. But really, John, Jeff, Matteo, and the team, thank you all so much, and thank you all for tuning in live. And we look forward to meeting you in person and or hearing from you. And goodbye from New York, goodbye from Suffolk, goodbye from Barcelona, and goodbye from Nebraska. So take care, everybody.
Cheers.